we're going to talk about composite functions now. And a composite function is a function that is made up of itself other functions feeding into each other. So we take inputs to outputs. So suppose that I have f of x and a g of x. And what I want to do is I want to take my output from g of x and plug it into f of x so that I have f of g of x. So I plug something into g, get a value, plug that into f. This is our composition. And the definition, the way we write this is we put a parenthesis, f, this is a circle, not an O, f composed with g of x. And we can create new functions this way. And so to show some examples of this, suppose that we have the functions f of x equals x squared minus 3 and g of x equals 2x plus 1. And so what I want to find is what is f composed with g of 2. So I look at this, and by definition this is the same as f of g of 2. So notice that we work this way. We take whatever's here and plug it into the first thing and then into the second thing. And we're only going to compose two functions together, but you could string these along to 3, 4, 5, or as many as you wanted. So the way we're going to find this is we're going to find g of 2 first. So 2 times 2 plus 1, which is 4 plus 1, which is 5. Now that I found my output to g, that's what I'm going to stick into f. So I take the 5 and I put it into f, and this gives me 5 squared minus 3, which is 25 minus 3, which is 22. So the answer to my original question is, if I compose f with g and then plug 2 in, I get 22. I can compose in the other order if I want. If I do g composed with f of 2, this is going to change things quite a bit because I'm going the other way. This is really g of f of 2. So first I find f of 2. So we take 2 and we square it and subtract 3. So that's 4 minus 3, which is 1. I then take this 1 and plug it into g. So I get 2 times 1 plus 1, which is 2 plus 1, which is 3. So if I reverse the order, I get a very different answer. So order absolutely matters when you're composing. Now, some of the times, what you're most interested in isn't a specific composition. You want to know about the general composition. So let's say f of x is x squared plus 2x, and g of x is 2x minus 1. And suppose what I want to know is what's f composed with g of x. So remember, this is f of g of x, and this is actually what we're going to do. Since we don't know what x is, we're just going to take whatever g of x is and plug it into the parentheses. So we want to know what f of 2x minus 1 is. And remember that wherever we see an x here, we replace it with what's in parentheses. So this becomes 2x minus 1 squared plus 2 times 2x minus 1. So g of x has replaced x in the f of x. This is a perfect square trinomial, so we square the first one, we times the two together and double it, and we square the second one, and then we distribute the 2x to get 4x minus 2, and we combine like terms. 4x squared is left alone, minus 4x plus 4x goes to 0 and disappears, and 1 minus 2 is minus 1. So by composing f with g of x, I end up with a new function, 4x squared minus 1. I can go the other way as well, because remember, order matters. If I look for g composed with f of x, then I'm asking for g of f of x, which is g of x squared plus 2x. Well, this changes things quite a bit. Now I get 2 times something minus 1, and that something is x squared plus 2x. So now I just distribute the 2 through, and I get 2x squared plus 4x minus 1. And again, the order absolutely matters. So you start close to the parenthesis next to the x and work to the left to get your result.